So I'd like to invite Wan Zanaria to present the chapter 4 summary, right, with the wonderful slides. So the rest of you, please prepare questions or discussion, right, after her presentation. All right, so over to you, Wan, right?
Okay, can you hear me? I see my slide sharing now.
Yeah, loud and clear.
Okay, hi, assalamualaikum everyone, and good afternoon. Okay, today I am going to present to you the things that you have read as well. Chapter 4, set before, met before, and long-term learning. Okay, let's see what we are going to discuss. Okay, first of all, we will see the idea of set before, and then the second one is met before. Please sit back, relax, and enjoy, as this is going to be a lengthy presentation, as it is involved the foundation of mathematics, counting, uh, subtracting, multiplication, fraction, uh, trigonometry, and also we will look through problems that the students encounter while learning. Okay, and then next. And lastly, yeah, we will see the supportive and problematic conception, how this conception met before. Some of it will help the students, but some of it may confuse them. So we will look through each topic. And lastly, the summary. Okay, without further ado, let's see. Let's get started. Okay, the first one, idea of set before. What is set before? Set before is basically mental structure that we are born with at early life. So there are three foundation of set before in mathematical thinking. The first one is a recognition of patterns, similarities, and differences. This recognition maybe involve vision, smells, touch, sensorial. Okay, and the second one is repetition of actions. Okay, by repeating one action may lead may increase the mathematical thinking. And then lastly, language. Language is the most important thing that define us human compared to other human species, like what Hazman have presented earlier last week. Okay. This language also help us to explain the concept of, for example, trigonometry, the concept of theorem Pythagoras, tangent line, and so on. Okay, so this is very helpful. Um, like each country have their own language, and it's good that we have English language for all countries as a medium standard. Okay, just a quick sharing on how you can improve your kids' sensorial. I want to share more about this, but this might not be a main topic. Okay, just want to share with you by repeating. For example, the shoelacing tightening the shoelace. Okay, we don't expect the student to tie their shoelace by themselves straight away. You have to give some practice like this. This is what we call sensorial board. And also maybe that include the lock and unlock so that they won't get trapped. Okay, let's say in the toilet they can rescue themselves. Okay, this is a sensorial shaker. Okay, sensory bottles where inside the bottles have different materials. For example, sand, beans. Okay, and the students, the kids have to match with the blue color. So why is this important? By practicing this, the students will improve their hearing, which benefit later in life. In phonics, for example, how they distinguish the sounds of and n. For map and for nut. So they have to use all the sensorial clearly. So this is how we practice. Same goes to the students. For upper primary and secondary, we have to allow them to expose to a lot of practice. Okay. Okay, what is met before? Met before is how we interpret new situation based on our experiences, based on our past experiences. For example, students has experienced 2 square equals to 4, 5 square equals to 25, 7 square equals to 49, which is a positive number. But then suddenly when you want to introduce the concept of complex number, I square equals to -1, some of the students cannot accept that. Why? Because they have the past experience, the met before. So as a teacher, we have to allow them and give a lot of other than a lot of exercises, but also you have to explain the concept clearly. Maybe introduce them the different real number, um, natural number, and irrational number itself. Then only you introduce the imaginary I squared is equals to -1. Okay. And how about counting? Okay, the basic step, the basic before we talking about other higher level of mathematics such as fraction, ratio, proportional. First of all, the students at the kindergarten, they must learn counting, basic counting. Okay, so Joanna, for example, is a like ordinary students. She counted 8 plus 4, 8 in minds, and then take out 4 after 8, 9, 10, 11, 12. So that's normal. But these students, Emilia, is very special. She looks in different way by imagining 5 means 5 dots and 3 with 3 dots. By moving 1 dots in the middle here, can you see my cursor?
Yes. Yes.
Okay, so it's good that I move the cursor so that it's become clear to you. Okay, so once the students move the cursor, so he can straight away look at these 2 row and 5 columns, sorry, 4 columns, and the total give her 8. Okay. Um, okay, this becoming complex if involve okay, before that, graphing calculator. Okay, the use of graphing calculators, teachers might skeptical saying that why teach calculator need students to think by themselves what's and not. Eh? So what as a teacher we can modify the usage of calculator instead of asking the students what is 5 plus 4, what's the answer. You change the question to be what makes 9, so you will get the different answer. And in fact, the first one, 5 plus 3, student may explore 5 plus 3 8 and not enough to be 9, so they add up 1. So this will improve their met before concept, dia punya pengetahuan sedia ada with the additional concept. Okay, it's not just a 5 plus 3 plus 1 will give 9, but also 5 plus 4, and so on, maybe 8 plus 1, and so on. Okay, now counting. Okay, so counting, yes, maybe it's easy for us to see what makes 17. So 17 is 110. 110 is basically 10, 10, okay, and then we add up with 7. But some students, they cannot accept, like the language 110 means 10. So we have to be we have to be very helpful lah to the students and attend the students that cannot grab this concept of tens, because it's very crucial in further higher level of mathematics lah. Okay. All right, now look at the we have look at addition. Now let us look at difference, subtraction basically. Okay, so met before, the students already seen that 6 minus 2 equals to 4. Okay, maybe by using 6 object and then cancel 2, and what does the remaining object? 4. And some student count backward. Okay, 6 minus 2, so they start with 6 and then backward 5. After 5, backward 4. So this student also will get 4 answers. And maybe the students can, there's another students using count up. Okay, what is the smallest? The smallest is 2. After 2, to be 6. After 2 is 3, 4, 5, 6. So, okay. This met before, these previous experiences is good, but then it may affect the confusion when the students wants to solve this kind of question. For example, 14 minus 7. Um, so of course lah, we know 14 minus 7 is 7. So according to research, 32 students managed to get correct answer 7. 38 still get the correct answer, but a different, they carelessly put 0 at the front. So just correct them. But this is a problems. There's students, not one, but 20 students get 13. And why is this matter? Because this is a one whole group, not individual. Yeah. So as a teacher, we have to find out why. Why is this thinking can appear, can exist? Oh, this is because the met before experiences where they minus 7 with 4. What is the largest? 7. 7 minus 4 is 3. That's why he get 13. So it's quite dangerous. This is shown how the math before might bring benefit, but also might bring a confusion for the students. Okay, this is only for difference. Let's look further for grouping. Okay, so for grouping, some teachers are very strict. Okay, the 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 apa? The multiplication of 3 plus 4 means a group of 4 containing 3 and vice versa. According to Piaget, a child who has the concept of conservation of this multiplication, they will realize that either way, 4 times 3 and 3 times 4 will not affect the result. Okay. In fact, by teaching this like 4 groups and then a 3 object and so on might increase the stress level. Okay. Okay, next, sharing. Okay, before we introduce the fraction, the teachers maybe most of the teachers use sharing, like one cake share with 4 students. So each of the students will get 1/4. Okay. So yeah, that's really helpful. But then how are we going to, okay, for example, sharing 3 cakes between 4 children are still manageable. Okay, we will look through. Okay, this is how. 3 cakes, you want to divide with 4 students. So 1 students, second student, third student, fourth students. Okay, so each students have half of the cake. And then this 1 cake, they share to 4. So end up with 1/4 lah. Okay, so conclusion, each student managed to get half of the cake plus with 1/4. Okay, still easy, still manageable um, to teach the students. But then what happened if the question 1/3/4? How are you going to explain that? Okay, so it's getting tougher and tougher, and until most complicated fraction like 1/17/19 or 27 over 27/4. So sampai bila? Until when the students have to imagine that the sharing concept ni. Okay. All right. Now we move on fractions. Okay, this is there is a software developed by Toll 1986. I'm not sure whether this is the same person that Dr. Leong have said just now. Okay, he created a software that the students that allow the students uh, to play around, to explore fractions, including fractions that greater than 1. Okay, so this is 8/6, which consists of 1 whole cake with 2 extra pieces cake. Okay, and then this is 4/3. Okay, so this previous met before experience may bring benefit. at that time. Okay, the students 100% understand. Yes. But then how are we going to show the multiplication of a fraction 1 over 2 and 1 over 2? So it's getting tougher. So now the new experience we have to introduce maybe to help the students understand the multiplication is, for example, one apple cut into half, and then the half of the apple, the remaining half of the apple we cut into two. Then they will get a quarter pieces. So maybe that will help them to do multiplication. And at that time, it may be benefit them. Maybe it's yes, they understand. But then in a further complicated question like 1 over 7 times 3 over 4, are you still gonna present a cake and apples to the students? So that is what they discuss here. Met before might bring benefit, but also might bring confusion due to their existing knowledge. Okay. All right. Counting versus measuring. Okay, counting is easy. One cake, one apples means one apple. Two apples means two apple. But then, fraction cannot be seen as an object only. It can be a measurement as well. Like for this example, it doesn't state that this length is 10 meter, for example. Okay, it doesn't say that the tall, the width of this equal to 7, for example. They just use numbers. Okay, so for this example, we have 3 row. So 2 over 3 is the height. So this is what we call measure. This is how they use measure by using numbers. Okay, all right. And then 5, so 4 over 5. So how are we going to get the area of the shaded region? 2 over 3 times 4 over 5, the students will get 8 over 15, which is equals to 0.53. 0.53. We cannot say meter square or anything because it doesn't state. Okay. Okay, now we look further for negative quantities. When does this the students can introduce negative quantities? Is it form 2 thing? Negative numbers?
Form 1.
Form 1. Oh, as early as form 1. No, not at the primary school. Okay. So negative quantities. Okay. So previously, existing knowledge, they know 3 apples basically means 3. Okay. So how are we going to show that negative 3 apples? Even you gigit apple, even if you bite the apple, it won't give you negative 3, right? So it's easy to imagine 3 apples, but we cannot present the negative 3. So if the teacher stuck there, so the teachers cannot help the students. So we as a teacher has to find way to introduce them negative quantities. Maybe it's involve sea level, the upper sea level is positive and the lower level is negative, or maybe gardening, that involve gardening. But that also, ada juga research. There's a research also say that that might also confuse the students because they are extra knowledge, extra stories, and they have to think about sea level pula, and maybe the jargon that we are using. So this might be the alternative, might be helpful, which introducing a number line. Okay, so for example, if they are required to do multiplication 3 times 4, so basically a jump 4 once, twice, and triple. So 3 times 4, they get to 12. And how is the negative works? Yes, the negative also works. Okay, they jump to the left. But what if negative 3 times negative 4? So since you have introduced one negative, meaning reflect once, so twice negative will reflect twice. So once they already have at the left, so when they reflect, they will be coming positive. So maybe this will add up your knowledge on how to attend the students if they get confused with multiplication of a negative number. Okay. All right. Let's look at the higher level, minus sign at pre-college. As most students, many students, even I found the matriculation student also, they forgot to put bracket when they calculate or even using calculator. Why? Bracket is very important because negative 5 square, negative 5 in the bracket, give different example, give different answer with negative 5 square. This one end up with negative, but this negative 5 square will end up positive. And another confusion that exists among the pre-college students, maybe the positive, the equal sign, they they assume that, okay, x minus y is equals to y minus x, as it is the previous existing knowledge that they have is addition and subtraction is commutative. Dia boleh mana-mana je 5 tambah 3, 5 plus 3 is equals to 3 plus 5. So why not this? Once it's involved negative number, so the students must be very careful. So that is why the math before experience might affect the students' learning. When we want to introduce negative number, it might be difficult for them because their existing knowledge. So teachers have to compare. Last time they learn what, and now this time it's different because it's negative, and then substitute with the values. For example, x equals to 3. Give any positive number. Take any positive number, let's say 5. Takes any negative number that represent y, for example. So okay. So for example, our x is 3. So 3 minus, okay, just now y is negative 5 is 8. And then ask the students, okay, negative 5 minus with the x is positive 3, give us negative 8. So does it equal? No, it's not equal. So practice with them a lot and allow them, okay, to make mistake and understand why they have such a situation like this, because they have a previous experience, the commutative addition and subtraction, maybe the concept of difference. Kalau tolak maybe salah, but the difference, for example 4 minus 2 and 2 minus 4, the difference is 2, same kan. But then when once it form negative, it's wrong. Okay, next, transition of algebra. Okay, this one I rarely seen this lah. Maybe matriculation level, if they did this, melampau kan. This maybe at the beginning level when they once introduce algebra, maybe. So 3 plus, some of the students just add up 3 plus 4 because their previous experience 7 plus 3 is 10. So 3 plus 4 is 7 lah. And then just straight away turunkan x tu. So this is what the student will get. Sedangkan for the higher for the students who really master the concept, they don't just be able to add up add up only the x term with the x term and the constant with the constant, but also they can in fact they will be able to factorize, okay, for algebra. Again, previous experience will impact the current learning. Okay. All right, let's look at apples and bananas cases. So, for example, okay ke kawan-kawan? So far okay?
Fine.
Okay lah, I try to make it as fast as I can. All right. A stands for apples and B for banana. Okay. So not a problem to solve this. They add up the A terms, 3 plus 5, 8. And 4, okay, tak ada masalah. And in fact, when we ask them to substitute, maybe A is equals to 5P. So they just substitute A equals to 5P and then B equals to 3. And then, okay, straight away, not a problem. Okay. And we show them that apple 3A meaning 3 apples, 1, 2, 3, and 5 bananas. 1, 2, 3, 4, 5. Okay. But how do we explain to the students if 3A minus 7B? It doesn't make sense. How are we going to show 7 banana? Then suddenly I remember how I introduced matrices to my students. I said that X is mi goreng, for example, Y is mutabak, Z maybe tepung pelita. Okay, and then we are going to find what is the X, Y, Z values. But maybe some of the student might think, how can negative to mutabak? Okay, but maybe she just don't want to disturb the class. She just get along with me. Okay, so it's quite dangerous when we specifically state that X, Y, Z is an object. Okay, all right. Because negative to Y doesn't make sense if it is representing an object. Okay. All right, next, let's look at other confusion. Now, uh, they misunderstood A, the unknown just now, A times A is A square, which is A square is the area, which is wrong lah. But most of us teachers, okay lah, understand this. Okay, next, students and professor. Okay, let me ask you guys. Okay, I use different examples. I don't use students and professor. I give you a different example. Okay, so which one is the answer? On the left or on the right? The first one or the second one? The price of flight ticket to New Zealand are 5 times expensive during the pandemic. So let's say N for normal, normal, um, normal without pandemic, and then P with pandemic. So which one? N equals to 5P or 5N equals to P?
5n equal to p.
Okay. See, seorang je yang jawab. Yang lain?
Sama.
Okay, sama. Very good. So good lah all the teachers. But then some of our students will get confused. They simply put the 5 anywhere. As long as they nampak 5 times tu. And then they order tau. Okay. Flight ticket to New Zealand and then 5 times the pandemic. So simply 5P. So that's why the students in this level, they have to understand pandemic must be higher, must be expensive, more expensive. So if N is equals to P, 5N mean um, times 5 lah. If 2N mean double up the price. Okay, so 5N is basically 5N equals to P is the answer. Okay, good. Just now, who answered correctly. Okay. Let me take you to New Zealand. All right, this procedural and perceptual solution. Okay, some teachers based off this 3x plus 2, they introduce with they introduce the students with 3 cube, 3x, that the x we do not know what's the weight maybe. Okay, so that's why it remain unknowns. And then 2 marbles, 2 constant, and then equal. So at balancing beam, it's equal 6 6 marbles and plus 1 cube, 1x. Okay, so how to picture this? Maybe the teachers introduce two. How are we going to balance this? Maybe take out 2. Okay, and then take out the x. So one what's that? This one x, okay, and then end up with x equals to 2. Okay, but how? Okay, what if 3x minus 2? If this is positive, 3x plus 2, but how are we going to portray this balancing beam ni, 3x minus 2? So it's quite impossible, right? Negative 2. So yeah, that is why just now I shared to you maybe a number line, or I don't know, maybe any other method that you want to share later. Okay, how to show the negative other than using number line or sea level, or maybe this gardening on top of the soil is positive, below the soil is negative. Okay, But as I mentioned earlier, this will bring some of the students might find this confusing because there are additional ideas, additional jargon, additional noise for the students. Okay, so as a teacher, it's quite challenging actually. We understand it's easy that we understand the problems, but then it's so hard to understand how the students think. So by doing these courses, a little bit lah, we understand and empathy them more lah, and on how they are thinking. Okay, so analysis data in solving linear equation. Okay, in solving linear equation, there are many ways, but we can group into three. The first one is embodiment, which in other way we just call it drawing graph. Okay, and then symbolism. One of the method is numerical approximation, and the third one is reason. Okay, reason is basically the most done by students doing the same for both sides. Okay, let's look at the embodiment. So this is an example to solve linear equation. Okay, for x using embodiment, which by graphing and then by finding the intersection is basically the x that satisfy both graph. Okay, so in linear equation, this is one equation, this is second equation, and then we wanted to find the x and y again. So basically by doing the graph, the intersection of the graph is the x and y values. Okay, and maybe this is something new for you. Okay, symbolism, where we get the answer by using numerical approximation. I'm not sure in admits ada belajar ke tak ni but then in matriculation, yes, they learn this Newton-Raphson. Okay, what they did here is basically this is a function x cubed minus 2x plus x minus 3, and then they can either differentiate themselves or the question given to them, usually they differentiate themselves lah, and then they have to have the starting values. So okay, for example, the x naught is 4, and then they keep on substituting into the formula, but they don't actually use the formula, they use the calculator lah. Okay, all right, but you can see here, I want to get your attention. This one, the first one, they get 3, 2.4375, 2.2130. Okay, this one not enough iteration. Sepatutnya ada lagi, ada lagi. So I attach this second example to you. Okay, if you see 5.33, 5.31, 5.3166, 5.3166. So the values are keep on repeating until what? Until 4 decimal places. So that is the answer. So the answer, the x, okay, in order for us to solve x squared minus 4x minus 7, the answer is x equals to 5.316. Okay. Apa yang kita cari ni sebenarnya, we are finding the zeros, finding the factor. Zero is one of the factor, or we can say that we are finding the roots. All the three terms is quite similar. All right. All right, next, quadratic equation. Okay, in math before, quadratic equation, they simply know that square is square root. So uh, taking a square root can abolish the square here, can eliminate the square. So they will end up with one positive number only, the answer kan. So wrong, betul tak? Salah kan? So what they're supposed to do, guys?
Positive, negative.
Yes, positive, negative. So once they take out the square root, they must appear positive and negative. So therefore, they will end up with positive and negative 3. Okay. Otherwise, bring 9 to the left and then factorize completely. Okay. So this is how the math before will affect the students' learning at the current situation. So this is what I said just now. Okay. Okay, next. Right. Further difficulties. Okay, student met before, they know that 2 cube is basically 2 times 2 times 2. And in fact, they can multiply. They can multiply 2 cube basically appear 3 times, and then 2 square appear 2 times. So the answer is 2 to the power of 4. But then how? How we introduce 1 over 2 and 1 over 2? Okay. How are we going to write down 2? Okay. Of course lah, like as we know lah, 2 square root kan, because we already know the square root. But for those students who do not know the square root, macam mana kan? So because it's not integer. Previously they met before is the integer. So nak tak nak, they have to be taught these rules, the product rule, the multiplication rule. 2 to the power of m times 2 to the power of n is basically m plus n. Okay. Um, Make sure that the a is the same. In our case, our a is 2. Okay, so sadly, this is where deduction are used. Okay, by using power rule definition. That's why sometimes we always wanted to teach student maujud things in teaching maths, but some of it is not practical and cannot be represented by 3D object. Okay, next, trigonometry. Okay, the learning of trigonometry actually it's a journey. It's a journey to reach a level of analytic trigonometry. The students must face this Euclidean geometry of triangle first, which they learn in primary and secondary. So ada theorem Pythagoras, ada similarity, triangle similarity yang the one that we did with Dr. Leong at GeoGebra, I think. And then triangles, polygon, and so on. Okay. And then circle trigonometry. Okay, what is circle trigonometry? This one, I show you. So this is the one that we learn all science teacher crazy, add sugar to coffee and so on. Where the first quadrant is positive for all sine, tangent, cos, and the second quadrant is positive for sine only, and so on. They need to find the theta. Okay. So and then next is analytic trigonometry, infinite series. So this is the higher level. Okay. Maybe we encounter this during a university level. So it has been a long time we haven't seen this. And next is complex number. Okay. So next is this lengthy proof. Just a quick proving. This one I just add up after Dr. Leong requested just now. The proving of cos. Okay, where does this came from? Kan kita suruh the students hafal je kan. Okay, no need to memorize. It's provided in the formula at the front pages. Okay, so where does this come from? Okay, this is basically came from here. Cos alpha plus beta plus I sine alpha plus beta. So they are comparing real and real. Okay, when I say real, they doesn't have I at the front. Okay, so that's why ini dengan ini equal. So they get one formula, and then sine alpha plus beta equal. They're comparing with imaginary. In mathematics, yes, sometimes we cannot solve, but we can compare. Same goes to, for example, exponent 3 equals to exponent 2x plus 7. Okay, we can simply say that 3 equals to 2x plus 7, something like that. Okay, and then where does this function actually came from? Okay, so kalau you tengok on the right hand side here, this is the expansion. These are actually the expansion of this function. Okay, where does this came from? Ini sebenarnya daripada persamaan ini. Okay, exponent to the power of a plus b I. This is basically the power rule just now. Yeah, I mentioned 2 to the power of m is equals to 2 to the power of m times 2 to the power of n is equals to 2 to the power of m plus n. Macam tu. So when the exponent, okay, the what we call that asas, the asas is equal, so we can compare the power. Okay, so this is where it came from, but we don't, I don't know, in metric we don't introduce this lah. I mean we show once, but then doesn't really, they just use it later. Okay, next. Finally we finish the subtopic 2. We are coming to an end. So 3.0, supportive and problematic conception. Okay. So according to a researcher, there is a difference between knowing, like us teachers, we knowing, and grasping. Grasping means satu tahap, another level where the students or the teachers can manipulate ideas, can speak about conception and problematic conception. For example, the students that the author supervise dekat dalam buku tu did research on conception of trigonometry. Kita nak faham je conception of trigonometry. Dia buat research. They found a new theory of trigonometry. So this is the level of grasping lah, meaning that the students have grasping level. And then next, different individual may have some supportive and some problematic aspect. Maybe they understand this, but they don't understand that. So there is a hole, there is a loop, there is a dot. So it is us teachers to connect the dots. And then lastly, teachers need further reflection. Teachers need further reflection and custom the lesson according to students' need. Okay, these A students might not the same, might not facing the difficulties as the group B and C students. So after this, we will be more understanding, more empathy towards them. Okay, finally, in summary, in conclusion, we can say that met before affect us all. Okay, all our experiences will affect how do we understand something. Okay, but problematic ideas should not be hide. Should not be hide because it is for us to attend, to solve, to identify. So do not be down. Okay, do not humiliate our students. Do not downgrade them because the attend. Okay, even the researcher also sometimes when they find something, the formula, but it's not they cannot be generalized on these problems. So there is a hole, there is a loop. That what we call problematic ideas for maybe other researchers to continue done the finding. Okay. All right, okay, in conclusion, summary yang banyak, this is really a final conclusion. Mathematical thinking developed by human brain at the first step, and then language and symbolism, and it's continue to grow. It's continue to grow um, through successive experiences. Okay, and also maybe failure as well. Okay, so that's all for me. If you have any question, please ask. If you have any experience, do share. Thank you.
Right. Thanks very much. Right. Wonderful presentation. Right. From Panzanaria. Right. So if you have read this chapter, you understand the complexity of the mathematics. So she has summarized the important points, and it took really extended time. Right. I think if I watch my football match, it's finished one half already. Right. Yeah. So, but I think it's a very good presentation with all the important summaries for us as a math teacher. Right. From researchers' viewpoint. Okay. So let's begin our discussion. Right. Very quickly. Okay, Ili, start first. So I'm thinking what I can do is please raise your hands in the chat section. I think easier. All right. Then I can see who's the one we can call you straight away. All right, Ili the first. All right, yeah, then move on by who else. All right. Okay, let's start with Ili first. The rest, please raise your hands. Right.
Thank you, Kawan. It was amazingly summarized. I just want to add, I mean, from my experience, for the negative numbers, right, because we just introduced them when they come to Form 1. So number line, it helps when there is no bracket for the second number. If let's say we have 5 plus -3, then students already start to get confused because they still need to break the bracket. So for me, I use money illustration because they already become Form 1. They have used money. So I say you owe me money. So that is a negative number already. So I use that method kind of to help them. And for transition of algebra, I think I am guilty as well. to introduce them unknowns as objects. Then after that, I hope lah they will understand that it's not just about object, because when we put negative, we cannot show anything. And after reading everything, I feel like even for all the problems, I can conclude that introducing unknowns as object leads to a lot of problems in the future when they learn sophisticated mathematics and deeper level. So that's my conclusion. Thank you.
All right, wonderful sharing right, by Ili. Okay, let's move on. Next one, Desmond, and then Kita, then Hasban. Okay, let's next person. Yeah.
Oh, thank you for your presentation. I think when I read also, I find it's very difficult because there are a lot of content to summarize. So basically, after I read until the end, I forget what is the beginning already because there's too many subtopic. So I just want to ask for your advice from one that how do you teach especially the trigonometry ratio or this thing? Do you have any experience to share more? Because you're saying that the proving part, and then how about when solving part? Do you have any, like, I don't know whether you use any technique or you use storytelling or what in order the student to understand the trigonometry? Yeah.
Okay, you ask me, Desmond.
Yeah, correct.
Okay,
I'm asking you.
trigonometry, I think it's quite broad, like which
Yes.
which problems that you want to attend. So maybe we can have a later discussion. Like
Can
trigonometry
no
is very huge. Like which part you want to attend? Like all sine, cos, tangent tadi ke atau any other problems for
Daddy
trigonometry?
content too, especially Daddy problem too, especially the
Oh, add sugar
proving
to
part. I
coffee.
think the
Yeah.
student because
For me,
that so there's so many formula. Yeah, sorry.
no. For me, I don't introduce and I don't involve any storytelling or so forth, because I think to understand the storytelling will confuse them. Maybe I use wrong jargon or else. So just introduce the concept of the concept of angle, and then why, explain them why cos and tangent. So introduce the triangle, sine, cos, tangent. So why is it negative? Why is it positive, and so on. Okay, maybe we can have a later discussion with Desmond.
Can. No problem. Thank you, one. Thank you, one.
Yeah, okay, good question, right? Yeah, Trigo is actually quite difficult in certain parts, right? Certain sections, it's just a bit tricky and a bit of abstractness. Okay, let's move on. I think Gita, next one is G account.
Hi, Wan. Good job in your presentation.
Gita, they cannot see you,
Okay,
but you
so
can show your face or what? I don't know. They might want to see your face.
can you hear me?
Yeah, we can hear you. What you need?
Uh, Actually, I'm having a little bit problem with the camera right now. Yeah,
Okay,
because
then
I'm
go
like
on. Go on.
using this phone for the first time, like using the
Okay.
Teams and so on. Okay, so all right. Actually, I'm going to share something. If you guys have heard of something called algebraic tiles, you guys can use that thing when you're going to do negative values for algebra. And I've used it personally in my class when I did expanding algebra for factorization and quadratic and so on. So you can try to do algebra tiles. You can Google. They actually give you the whole template of the algebra tiles. So what I did is I photostated that and then I gave it to my students. So each and every one of them have their own algebra tiles. So when I'm teaching them 3x minus 2 equals to 7, so I just use, they actually have the negative tiles and also they have the positive tiles. So what will happen and everything, we can simulate to them. They can actually see it in front of them. So instead of using objects as your unknown, you can use the algebra tiles to make it much more better. So that's my add-on to this presentation. Thank you.
Right, thanks very much, Gita. Right, good idea on algebra tiles. Right, so you can have two types: the virtual, the traditional one, and now I think the more easily accessible is virtual one. So see which one is more accessible to you. Okay, let's move on. So very good sharing, algebra tiles. Next person, who's in line next? Okay, Hazman, your turn, Hazman. Yeah, then Chong Xian.
Okay, one good sharing just now. Very nice slide and everything. I just have one sharing that I want to share during this year SPM. Okay, the is regarding your presentation just now regarding the reasoning of the regarding the writing of the mathematical equation of the professor and student. Actually, during this SPM, I took the SPM actually as a calon mengulang. So yes, I'm also having difficulty in writing the linear equation because one question we have to draw a graph. So at first, when I summarize this book, I also wrongly write the
Professor
equation.
and student
Yeah. I
question.
actually the correct one is P equals sorry
5S.
yeah like that, right? So do you have
Mm-mm.
any strategy for us to to easily or not to confuse in writing this regarding the ratio where to put in terms of that mathematical equation? Thank you. Right.
Okay, for me, I understand this situation, but maybe doctor can adapt. I think it's especially kalau kita ada like trigo, ada graph yang like 3, 2. Itu lagi lah kan, like from M to N is 3 and then from N to P is 4. Itu bring a lot of difficulties where it doesn't involve object pun, it's only involve values. So it possibly can be many things. Maybe doctor have a suggestion.
Yeah, I think one way, like there's many ways I've seen is to visualize, is to write out. I think write out in like a diagram or I would say the representation. I think you can use
Yeah.
the Singapore, the model method. That's one way to visualize. I think that helps a lot.
Right.
That's the
Okay,
easiest
Hazan.
way like, to help us. It not means it's abstract, and sometimes we misunderstand the concept. When we draw it out, it helps to see the portion. I think usually through the model method one way. All right. Okay, so very good questions. All right. Yeah. Okay, move on to Chong Xian, then to Juan, and Ting. Pretty, right? Let's move on. Yeah.
Okay, so actually, thank you, Juan, for sharing us some of the slides, really nice that you did. And for me, be frank, Newton-Raphson method and the analytical trigger is also learned during my STPM. So if I was a teacher, so for me, I would like to give them some idea on how to solve the problems regarding especially the trigonometry, because during SPM 2019 there was an article said that the trigonometry is too difficult until students cannot do. You already in the article. So, but I actually see the questions, the SPM 2019 actually is not really, it's very simple, but students cannot do. So, for me, if you want to teach this trigonometry, really need some problem solving. It's just that how do we solve this problem? So you have to generate some idea to teach the students. This is my own opinions here, but well done. Thank you. That's all from me. Next.
Okay, next person, right? So move on, right? Once finish, who's Dudren, then after that Ting, then Pretty, Yuling, and then Shida, and then Insan, right? So just move on, right? I don't have to call you. Just move on based on the list of names, right? Okay, let's move on. Next person. Dudren, yeah, continue.
Yes, uh, yes, I think this is a wonderful presentation, and I want to discuss about the foundation of set before in mathematics thinking, and also my experience. I think the recognition of the partner, similars, and the difference, also repetition of action to build into repeatable the sequence. They are all human series. Input and output is they are also very important and useful, because before I have taught a student, he is a special child with stunting and a little autism. He is 4 years old and can express his thoughts in words. Also couldn't work as he was 2 years old. Therefore, his mother set up for a sincere cause for him. And in China, this kind of sincere course is very popular for children in pre-school education. It mainly trains the course of the perception and cognition unity through continued improvement of the cognition and repeat the practice to achieve the effect of training. After more than a year, he can work like a normal child, although he still can't speak. Maybe if he has those kind of class and can continue in class, he will have a big progress. So I think the two foundation is very useful. That's all.
Okay, continue according to the names that been called just now. Silakan.
Yeah, move on. Move on. Next person. Ting, Pretty, Yiling, Shida, and then Nisan. Yeah, continue.
Ting cannot hear you. Am I the only one that cannot hear?
Yeah, we cannot hear your Ting. I think yeah, but audio not on. Yeah, Ting's audio. If
Okay,
cannot, means
maybe.
we go to Pretty first, right? While you adjust technical, right? No, okay, Pretty move on first after we come back to Ting, right?
Okay, doctor.
Yeah.
Okay, thank you, Kawan, for the beautiful presentation. The slides also was very nice. I just want to share with you a few things. For the minus sign, right, the article on the minus sign. So usually when I teach the students, for example, the -3 square, they will, when they calculate, they put inside the calculator, they will not put the bracket. So they will get the -9, and then later on, everything, all the calculation will be wrong. So I always tell them to put the bracket. So that is one thing that I always see students, they make mistakes. And then like another one that I focus was on the grouping. So when in grouping, like last time, I remember when I was in primary school, we got learn the multiplication that like 4 times 3. I'm still confused until now. Means there are 4 groups and then 3 balls inside, or maybe 3 groups of 4 balls inside. So always like that thing, always I get confused. But the easier thing is I always tell them that 3 times 4 or 4 times 3 is also topic. Got a lot of things. Yeah, one more also. One more is algebra. When they want to solve the equations for the algebra, like for example 3x equals 6, let's say 3x equals 6, I always I teach them to divide on both sides. Previously I was teaching them to bring the 3 go opposite, means you bring it underneath. I taught them, but I found they are very, like, they're confused. So I teach them, you divide 3 on your left, means you divide 3 on your right also. Do it fair and square. So that's how I teach the students there. So that's all from me. Thank you.
My turn. Can you hear me?
Okay, Ting, can.
Okay, yes, finally.
Thanks
Okay.
for the one amazing presentation. Very good. No comment, but I just want to share my experience about the trigonometry ratio. I think it's from 3 chapter, chapter 5. Then I want to show something. Okay, this one.